All right. Good morning, everyone. Without further ado, I get to bring onto stage for his very first opening keynote, giving us all an introduction to the self-writing internet, the man, the myth, the legend. He's already waiting in the wings. Let's give a very warm welcome to Dominic Williams, founder and chief scientist of the DFINITY Foundation.
Oh. Am I on? I am on. Good. Hello, everyone. Thanks for coming. We got a great event lined up for you today, and I think this is a new paradigm you're going to see, and it's exciting. Before getting into that and talking about it, I just want to say thank you, first of all, to everyone that's been working behind the scenes on Caffeine. So the backstory is probably this event should have taken place in about a month's time. And for a bunch of scheduling reasons, we sort of brought it forward. So it's been very intense. But here we are, and thanks for coming. So let's get going. All right. So for those of you who don't know me, I'm Dominic Williams, founder and chief scientist of DFINITY Foundation. DFINITY is actually a non-profit organization, but we got some commercial spin-outs coming in areas such as self-writing. And the mission of DFINITY is really to make compute secure, resilient, and sovereign, and also to enable the self-writing internet, which plays into those goals. 250 team members worldwide, was it a split between the US and Switzerland, and come from a mix of backgrounds. Oftentimes big tech, but also some people like me from early days of crypto. So the big step, I think, with the self-writing internet and self-writing apps more specifically, is that in the future. And really now with this technology, app development is a conversation. So this is really something very different to what we're seeing today with vibe coding or traditional development. So to sort of put this in context, I want to cover the 4 ways that you can create internet functionality in the form of apps and services. So internet, of course, modern internet came into being in I think, January the 1st, 1983. Back in the early days, the only way to build something on the internet, obviously, was craft coding, as we call it now. And craft coding involves a human being with a keyboard typing out code. And the internet went through various phases. So to begin with, when you created an internet app, you coded the low-level protocols. So that's actually how I started. I started writing in C and creating and managing sockets and things like that that today people don't really think about anymore. Then along came HTTP and the web, and that kicked off a whole revolution and began this kind of exponential growth of the internet. But there were further revolutions that followed. Then there was mobile, then there was cloud, and that kind of changed how we built things on the back end. And now, of course, more recently, perhaps the most profound and accelerative revolution of all, we've gained access to these really powerful AI models. So 2 years ago, 2023, along came, right, the clicker, thank you, there is one, thanks. Along came Cursor, and that kicked off a whole new, maybe it doesn't work, it's all good. That kicked off a whole new paradigm, if you like, vibe coding. And Now with vibe coding, you still have an engineer who's typing out code on his keyboard, but in addition to that, the engineer can issue natural language instructions to AI. And with vibe coding, it's those instructions tend to be of the form like, rewrite this function, something like that. So the latest paradigm is self-writing, and that kind of starts about now. And the change with self-writing is that the entire app lifecycle is a conversation. So rather than having an engineer typing code at a keyboard, you can have a completely non-technical person or a technical person just interacting with AI in a conversation, which is triggering successive updates of the app and successive deploys of the app almost on a continual basis at sort of chat speed. Of course, anyone could implement a self-writing paradigm platform, but today we're going to be talking about the way we've done it, which is this platform called Caffeine, which has an ensemble of AIs inside. The AI writes to the writes code in a language that's specialized for AI called Motoko, and that's that kind of friendly ghost icon you see. And then it's deploying it to ICP-based networks, in this case, the public incarnation of ICP called the Internet Computer. And we'll get to the reasons for that later. So I think what's probably going to be the case with most self-writing platforms going forward is that they utilize new tech stacks that are specialized to support self-writing. Because, in fact, AI, of course, has become very good at coding, but it's not a human. AI is an embodiment of human spirits in a kind of stochastic way, currently at least. And it has its own idiosyncrasies. And in fact, within the context of something like self-writing, it's being asked to do something that no human can do. It's writing code very quickly, and it's also updating and migrating running systems almost in real time. So the best way to do that is to provide AI with a tech stack that is specialized for the needs of self-writing as opposed to vibe coding, which is using a traditional tech stack, or craft coding. So yeah, there we go. Now you might be wondering, this obviously I mentioned there are 4 ways. Before moving on, I should say that these different paradigms are going to coexist. I don't think craft coding is going to die. I hope not, because I've spent many decades writing code. I think there are always going to be cases where, maybe for reasons of trust, a human being has to write the code. I think probably in the future there won't be much pure craft coding. It'll generally be vibe coding. But these things will coexist with self-writing, and in fact, with Caffeine, we will open up hooks that enable it to be used in a vibe coding pattern. And of course, there are APIs on the Internet Computer that any craft coder can use. So just to be clear, none of that's going away. But you might be wondering what the 4th paradigm is. And it's what we call the fluid web. And you can get a hint of what the fluid web will be by looking at something like Perplexity, which is kind of like a search engine, but it kind of combines all these different sources of data and makes kind of a new informational resource for you. If you can imagine the equivalent of that for functionality, where AI is just generating the user experience on the fly, and that user experience can incorporate and combine functionality from lots of different apps. I mean, if you wanted, you could create a layer, and you could turn the entire existing web into a sort of library of microservices or something, right? And then you could have an AI layer over the top of that on the fly combines that functionality and creates a user experience for you. Like, for example, if you want to book a flight, it could create your own version of Kayak, but with some more telemetry, giving you indications what's the best price and so on. Okay, so let's get back to self-writing. So I think one of the really important things for me is that self-writing app lifecycles can be smartphone conversations. And that's why on either side of this main stage, you can see two screens that are feeding off a phone I've got here on the podium with me. Smartphone penetration is incredible. So by 2022, 82% of the US population was a smartphone owner. And this is a staggering level of penetration if you think about it, because it shows that even older generations have sort of given in and ended up with smartphones. In fact, my mother, she held out until about 10 years ago with a Nokia. At some point, I think my sister forced her to get an iPhone. And there are almost 1 billion smartphone users in China. So extraordinary number of people that can engage in creating self-writing apps. And as one of these charts mentions, there are now more phones than people in the world. So self-writing will democratize app creation and app ownership at an absolutely massive scale. And let's try and put this in perspective from the perspective of developers, as I'm sure many of you are. Within the field of Web3, there are only 35,000 specialized engineers. It's probably why so much of Web3 is stuck in the mode of creating meme coins and things like that, right? The shortage of people developing more meaningful tech utility. Worldwide, there are about 15 million. I mean, no one can know the exact number, but this was the best I could get online. 15 million full-stack engineers. But there are 5 billion people with internet-connected smartphones who could be tomorrow's engineers because they're able to communicate in natural language and interact and engage in these conversations. And essentially, in the future, natural language alone will unlock sort of tech team superpowers. So I think the important point is it's not just that you're being a better engineer as you are with vibe coding. In the future, you're going to have a conversation with self-writing platforms. Under the skin, it'll be an ensemble of different AI models. And they're going to act as a complete tech team. But it's going to be very transparent for the user. I mean, they're just going to have this conversation and things are going to work. And that's what self-writing for us. Now, what does this mean? Like, how will this change the world? Well, I mean, first of all, I think whenever you get a new paradigm, you get a new tech stack. I mean, if you think back to the early days of smartphones, I actually had a device called an XDA, a Microsoft XDA, back in like 2001, I think, or 2002. I'm getting lost, but maybe it's later. But long story, it was after the dot-com crash, and I ended up brokering a sale of these phones to Cantor Fitzgerald, about 1,000 of them. Anyway, this smartphone is about that big, actually had sat-nav on it and stuff like that. But in the end, like, Microsoft lost the smartphone race because a smartphone is a new paradigm, and it needed a new tech stack. And the built-for-purpose tech stacks were the ones that won out. So, of course, in the end, we got Android and iOS and so on. So that's one way that self-writing will change the world. We're going to see new tech stacks, as you're going to see today, that are really being built for AI as much as they're being built for humans. They're being built to support self-writing. But there's more to it than that. It's going to enable new online paradigms. So there's this great quote that I love from Steve Jobs, and he said, "What's important is that you have faith in people, that they're basically good and smart, and if you give them tools, they'll do wonderful things with them." So what happens when you put these kind of incredibly powerful tools in the hands of the everyday person? So here's one of my guesses. It's called hyperlocal social media. Hyperlocal social media, of course, is something like a social network that you create for your extended family that has functionality you couldn't do with a public social network, and maybe a whole lot of special features. So here you go.
I created a hyperlocal social network for my family. My dad posted a dancing video. My sister and I added giant emoji reactions to the video.
So we'll see that kind of thing. And look, I mean, why? Because, I mean, you couldn't have Instagram where people could come and put great big huge emoji reactions on your photos. It would be defaced. But within the context of an extended family, you could do that. And, here a tween daughter can put giant stupid emojis on her dad's dad dancing video, and it's all good. Okay, so that's one thing. Here's another thing I think we'll see, hyperlocal esports. Actually, one of the problems with esports generally is it's very difficult to prevent people cheating. That's why it's often done in stadiums. It's very easy to hack it. And one of the biggest problems with public game servers, things like Call of Duty, is there's all these bots, and it's kind of unfair. And this really makes it very difficult to create esports where you might have like a cash prize or a Bitcoin prize or something like that. But if you're just doing it with your mates and you're creating the esports, the hyper-local esports platform for yourself.
I created a hyper-local esports system for me and my pals. We compete playing browser-based games for a Bitcoin pot.
Possible, right? That's another example, I think, of the way things are going to change in the future. The way we see the internet will change. So those are really consumer examples. I think it's heartening to see that the evolution of the web and the internet and the paradigms that exist hasn't really ossified in the way that we might imagine. It's probably only just getting started. The enterprise, of course, is going to make huge gains in terms of efficiency and velocity. So here's a kind of breakdown. Entrepreneur startup, one-person startup. I mean, you've probably heard a lot about that. I think the one-person startup meme is actually very real. Startup from the developing world, like that's a big deal. Like, I lived in Silicon Valley and Palo Alto for many years, and I can tell you it's much, much easier being an entrepreneur in Silicon Valley than it is in London, where I came from originally. If you're in the developing world, I mean, very difficult to be a startup entrepreneur. But these kind of tools are going to help people. They're going to democratize access to the tech economy and bring a lot of new talent in. Even if you've got a big team here, you're going to get more velocity. You could use it for personal branding and community, like create yourself a personal branding website and some kind of like social media attached to it. You can use it to design advanced Web3 functionality. So one of the interesting things with the Internet Computer is it's powered by a lot of, it's a mathematically created platform, and it's got a lot of very interesting cryptography inside, so it can interact with Web3 blockchains trustlessly, so you can do that. SME, I mean, e-commerce website, tennis booking session. But then you get into the NGO space, and you can imagine it, refugee assistance, a school district fundraising project, but also within the corporate and government environment, there's a lot of applications. And we've been doing early demos to governmental agencies, and they're very interested. Because, of course, it's really hard for them to develop stuff. So there's the obvious applications like CRM and ERP and workflow management and intranet portals. But you can also give like departments a certain level of independence. So we've really been talking about self-writing apps. For us, the self-writing internet is the self-writing app paradigm, which could be built using a sort of dedicated new stack, which is more traditional. But for us, the self-writing internet involves sovereign apps too. So this is how we've done it. I mentioned before, I work at DFINITY, and there's a network called the Internet Computer. Huge amount of R&D work's gone into creating this over many, many years. And it's a public decentralized network that creates a kind of cloud. Too much to go into the details, but essentially it combines like a giant virtual execution environment with a mathematically secure protocol. And that mathematically secure protocol actually combines machines, specialized machines called node machines that run all over the world, by independent parties called node providers. And so to recap, what you're going to see today is you've got the Internet Computer, talk in natural language to the Internet Computer, like I want the app to do this, I want the app to do that, and just keep upgrading it by continuing the conversation. And Caffeine is going to be coding and managing that app on the Internet Computer, and then the app is going to be available on a URL. Without getting into the weeds now, you basically update it in draft mode, and then when you're happy, you kind of push it live, and there's a kind of fluidity to the way this works, and the AI can kind of meld different code bases, as you're going to see. Now, a few people have asked is, well, what if I'm from a corporate or government background and I don't want to deploy an app to the Internet Computer? Well, the answer is, there's a product coming called Utopia. Utopia is actually an acronym for Unstoppable, Tamper-Proof, Open Platform for Independent Autonomy. That's why it's called Utopia. And it enables you to create like a private Internet Computer, and you can just run that over existing cloud services if you want. Or alternatively, your own dedicated hardware if that's important and you want to make sure that everything's under your complete control. That's it. I think I was going to, in the future, the internet will be self-writing. And today, you're going to get some real cool demos from me with some more technical details on some of the ways that we've achieved the advances we have. I'm talking about something called enhanced orthogonal persistence. So we've got this new computer language that essentially collapses the distance between logic and data. Actually, it's a great simplification of software. It's just got a horribly technical sounding name, unfortunately. I'm going to talk about that. I'm going to show you how we can build things just by talking, and then try and as well back up into how exactly that's working, and how this magic's being achieved. Okay, so I'll see you all later, hopefully. Thanks very much. Thanks.
All right, so you've gotten a bit of a theoretical introduction to the self-writing internet. Welcome back. I hope you enjoyed your extensive lunch break. I now have the pleasure of welcoming you all back for the first afternoon session. For those of you who ventured outside to enjoy some refreshments, this is your official invitation to come back inside, grab a seat. For those of you who have already taken your seats, I would kindly ask you, if you're sitting on the end of a row, to maybe move inside just to make sure that others coming in will be able to fill in seats easily. All right, just a quick couple of housekeeping items once again. We're going to ask for your attention for about an hour or so. So just a brief reminder, if you are looking to chat, you will have an opportunity to do so in just about 60 minutes time. For those 60 minutes, we do ask for your attention in order to ensure that all of the different speakers have a pleasant experience on stage and that they are able to impart their wisdoms upon you. All right, without further ado, it's been teased in the morning. You've seen a couple of snippets online here and there. If you tuned in on the 3rd of June, you have already seen your very first glimpse of Caffeine. But for those of you who are monitoring the agenda online, you'll also know that we're now officially heading into the demo portion of the day. So, without further ado, let's bring back to the stage Dominic Williams, founder and chief scientist of the DFINITY Foundation, as he shares a demo and some insights for the next couple of minutes. Let's give him a warm welcome back.
Hello, everyone. This is going to be an interesting one. So we are going to do a kind of technology demo. There's a last third session I've got where we're just going to go all out and start creating e-commerce websites and things like that just through prompting. But this is a difficult one. You know, sometimes like you can get lost in what sounds like hyperbole. You know, this morning we talked about what self-writing was. We talked about these 4 different paradigms for creating internet functionality, you know, craft coding, vibe coding, self-writing, and soon the fluid web. But how does that, you know, in all of that, sometimes it's good to think about what are the unique building blocks, what are some of the technical advances behind these new paradigms that are making them possible. And what is the kind of technology that powers a new tech stack optimized for AI that's working in the mode of a tech team. So there's one particular technology inside this stack I want to talk about, and it's got a very technical sounding name, enhanced orthogonal persistence. But I want you to try and resist the natural temptation to switch off when you hear a technical sounding term like that, because actually this technology is designed to simplify software, and it's really key to the way that we're able to enable AI to create much more sophisticated backends. And since we're in Silicon Valley, and this place is all about the tech, I wanted to have a go explaining what enhanced orthogonal persistence is. So we're going to run through this quickly, and then actually just start using the app, and you can see it working in practice. Okay, so what is enhanced orthogonal persistence? Well, it's really a system that completely rethinks data persistence. Data persistence, of course, is just refers to the process of making sure that you don't lose your data. You know, if you think about going onto social media, your posts are still there. The next day you visit, that's because they're persisting. And more generally, all data has to persist. And this technology aims for simplicity, so there's no database. So when Caffeine is building apps that are being deployed to the internet computer or some other ICP technology, there's no database involved. And it has flexibility in the sense that the data that's persisting can have any form whatsoever without any restrictions. There's some safety guarantees which are very important because this morning we talked about how there are approximately 5 billion people worldwide with smartphones. And since the app lifecycle is a conversation, potentially there could be 5 billion app developers out there. And there's no way that there's enough technical people to, fix things for them if they go wrong. So there has to be inherent safety, and orthogonal persistence, as we'll see, provides that. And lastly, just behind me, it's extremely efficient. Orthogonal persistence is much faster than keeping data in a traditional database. So we're going to whisk through this again. It's a bit of code, but if you look at it, it's actually pretty straightforward. This is what enhanced orthogonal persistence looks like. It looks like there's no persistence. You just write your code and your abstractions, and your data persists in those abstractions. So here within what's known as a software actor, which you can think about as being like an object, we've defined a post. The post has an author. It's got some media. It's got some likes, a set of users who've liked it. It's got some comments. And a user, of course, has a name and a list of posts. And then down the bottom, just like you would if you were creating transient data, it says let posts, which say, for example, the posts in a blog. Let posts be a list, which is an abstract data structure of posts. And to be clear, these aren't special classes that are, storing things behind the scenes in a database. This isn't a object relational database mapper or something like this. You can write arbitrary code. You can write arbitrary abstractions, and your data will continue to live in those abstractions. And the way I refer to this is that we've made a kind of effort to collapse the distance between code and state. So logic and data, code and state, they're kind of one and the same. And therefore, when you want to persist something, you don't do anything special. It just happens orthogonally. It's just plain code. Data lives in your logical abstractions. There's no database. There's no storage API. There's no files. So despite that crazy technical sounding term, enhanced orthogonal persistence, and despite the complexity of implementing this kind of technology, we first started talking about it and working on it in 2018. So that gives you an idea of how much work was involved, and probably we're going to get very near to the final version of it in August. Okay, so why does this help? There are a number of reasons this helps Caffeine. One of them is that we're fueling the modeling power inherent in AI thinking. So AI is very good at seeing patterns in text, and of course, text is language, and language embeds concepts, so you can kind of combine concepts. And that's how LLMs produce such marvelous results. And this can kind of be translated into, textual descriptions of the logical abstractions inherent in those apps that you're building. And enhanced orthogonal persistence enables arbitrary structure without any of the kind of limitations you'd see when you use a database. And you can kind of modify data as code. So here we go. We've got a function here that creates a new post and so on, and adding posts to the list and so on. We also get guaranteed data consistency because the data is part of the code now. And obviously that means it's kind of automatically type safe, depending on the language. Functions execute as transactions. Either the changes to memory are persisted or they aren't, if there's an exception. Data is type checked. And here's the really key one. Migrations are safe. So here you can see some code that I've just circled. And this is defining a data migration. So when you're using Caffeine and you go from one version of an app to another version of an app, logic is written that transforms, if you like, the data embodied in those abstractions from one version of the app to another version of the app. And what we're able to do through validation is make sure that if there's a mistake in the logic, because remember now the data's in the logic, if there's a mistake in the logic, and you can kind of validate logic, if there's a mistake in the logic, the upgrade fails, which prevents data loss. And this is a subtlety that is incredibly important within this field. If you want to let AI that can hallucinate, or not can, will hallucinate. I mean, AI makes mistakes. And you want to have AI upgrading apps over and over and over again at the speed of chat. You need to have guardrails that ensure that if a mistake is made, data cannot be lost during those upgrades. And it's not enough. I mean, Caffeine allows you to work in draft mode with a draft version of the app, and then when you're happy with a particular version of a draft, push it live. And you could say, well, it's down to the user. The user needs to make sure that every single migration has worked successfully and no data's been lost. It doesn't really work because data loss can be very, very subtle indeed. So if you can imagine a complex business system like a CRM, there's all kinds of different data in that CRM, and somebody might, upgrade their CRM, think everything went well. 2 weeks later, you realize there's been some very subtle data loss, but now you've been running the new version in production and you've collected new data and you're in a big mess. So actually, one of the most important features of any self-writing system is that you can guarantee that when these migrations occur, data isn't lost. And orthogonal persistence, as well as unleashing the kind of modeling power of AI, also creates guardrails, because now the data's in the logic, and we can kind of like process that in a slightly different way, and we can make sure that data doesn't get lost on updates. So lastly, before we get into something less technical in the form of a kind of demo, play around, one of the cool things, obviously, is that you've got instant access to data. It's not stored. The code and data is one and the same. It just comes straight from a persistent memory. And when you run an upgrade, you can just pick up existing memory and process it. And if you're a software engineer, this perhaps makes more sense to you. But anyway, let's move on to a demo. We can see this working in practice. Yeah. All right. I'm going to have to go here. You can see the workings. Here we go. All right. We're going to do some fancy demos later. What I want to do here is create something reasonably simple so you can see how the code changes and how the data is migrated. So we'll start off by just doing something perversely simple, maybe like a blog. Okay, create a user blog is, oops, God, of Medium. Yeah, let's just go like that. Let's see what it says. So it's actually got going on this right away. Something else you'll notice about Caffeine is whenever you ask it to do something, it always starts with the spec. And in actual fact, Caffeine doesn't use an elongated context. It tends to work by creating a spec, creating an interface between the back end and the front end. There are different models working on these things. And then writing the code according to the spec. And when you update okay, let's make sure on that. When you update, someone just brought my attention to it, you can now see the mobile version of the app working in synchrony. When you update, it's first updating the spec, and then it's looking at the existing code base, and it's updating the existing code base to match the spec, but it's the spec the functional spec that anchors it. So this is coding away, and I should point out that it's still very usable on mobile. And this is incredibly important to us. Like, mobile users are first-class citizens. In the end, all kinds of exciting things are going to be created using smartphones alone. But having said that, it's easier to demonstrate this on the desktop. So I'm going to click on this file here, main.mo. And main.mo, let's get rid of the chat, so I have the whole screen for it. Oops, excuse me, just unpin this here. OK. Main.mo is the back end. We're able to create backends extraordinarily quickly. And in fact, this backend would compile in probably less than half a second. And that's, again, the benefit of this language, Motoko, that it also implements enhanced orthogonal persistence. Anyway, I mentioned how there are no databases, there are no files. And I don't know if the text is big enough, but you can see a definition here for a user profile. And this has a bunch of fields. The first one is principal. Remember that the internet computer is, in fact, a cryptographic system. It's not usernames and passwords. It's a public key. Then there's used for gating access. Below that, there's a display name. Below that, there's a bio. And below that, there's a profile picture, currently a URL to a profile picture. And then it's defining an article type. An article's got an ID, a title, some content, an author, which is the principal, a flag saying whether or not it's published, a created at date, and etc. And this lives just in these abstract data collections, which can be arbitrary. So user profiles is just a map between the principal, which is the underlying idea of a user, and the user profile object, which has their friendly name and bio and things like that. Articles is an ordered map between text, which I guess is probably using a textual ID, and the article itself. And interestingly, there is file storage. It says file storage equals file storage.new, and I guess that's an array of a collection of binary arrays used to store images. So let's see where we are with that. Okay, it's working on some front-end stuff. So while we're doing that, let's create another project in parallel. Let's go. Create a user gallery, user photo gallery. That enables users to take photos from their device. I'm just going to see how it goes with that. It's very simple instructions. I mean, generally speaking, you probably okay. So this thing apparently is ready. There we go. Hold on. You can see it. All right. So put that back on. Interestingly, in that one, you see that the AI, it took a bit longer because the AI reviewed its own code, found errors, and then resolved the code issues, and then reviewed the code again for errors, and then it was happy and, yeah, built it. OK. So I can actually open this in a separate tab. Okay, well, very simple so far. We've got some much crazier demos coming, but let's go. Okay, I'm logging in with my fingerprint using internet identity. So, little factoid. Internet identity was actually the world's first passkey-based identity system in production back in May 21. And there's a new version coming out after 4 years. All right, so, yeah. So I've logged in, and we're just going to add some data just so I can show you when we add new features how the code changes. So article title, I'm on stage at the cafe. Okay, I need lorem ipsum. Blah, blah, here we go. Save draft or publish. Let's just publish it. Woo! Very cool. All right. Write another one. I'm just going to add 2 to prove it works. This is why. Okay. Highlight that. There we go. Whatever. Okay. So what have we done? We've created a pretty simple. Let's get back to articles. There we go. We've created. We've created a pretty simple blog. It says it's posted by anonymous. I think it's probably given me, edit profile. I could give myself a name and Dom. I don't know if that's going to work. I work on. Okay. Okay, well, let's go back. Yeah, it has, it's taken it, isn't it? Okay, there we go. So we've got a bunch of, someone is actually looking at this because I didn't use, anyway, I don't think I did that. Anyway, okay, someone's logged in. So let's go back to Caffeine and think about the features that we could add. So, where's our code? Hold on. Ooh. This is going slowly. I'm on dev. What are we going to add? Let's add tags. Make it possible to add. Let's do comments. To add tags to posts. Yeah, let's just do that. It should be possible to define a list of valid tags. All right. Okay, so some different internet speeds here. So we can see on the mobile app, we've flicked over to spec. This one, it looks like I've not clicked back into the toggle mode, so I'll leave it. Wait a second. It's working on mobile or not? Here we go. Okay, so great. Let me just close this here. I'm just going to turn this off here on this one. And look at the code. Okay, go to the chat. So the reason I wanted to get rid of everything, just so we can look at the code, is, okay, keeps flicking back. We want to see in this the ability to add tags to posts. And this could be the first time I get caught out. Let's have a look. So just take the chat here. Okay, so actually here's something interesting that you're seeing going on. You can tell this is a live demo that I didn't check before. It says that it's fixing the migration logic to protect your app data. Well, it didn't detect that the migration logic that it had written was wrong. Quite literally, when it tried to do the upgrade, it was rejected because it would lose some data. So this actually is an example of the power of orthogonal persistence in practice. The AI's made a mistake. Something's going on. I'm not exactly quite sure because it's jumping around. But it hasn't allowed a broken upgrade to take place. It's blocked it. And although it's kind of funny within the context of this demo with what was going on with it, if you imagine a system where, or a future where apps are actually conversations that people spend, months in refining things, adding features, making them more complicated, and the data gets more and more complicated inside these apps. Can you imagine if they're upgrading something at the speed of chat, talking, and they create a bunch of drafts, and eventually they like what they get, and they push it into production, and then it loses some data, and they don't notice? It would be a catastrophe. So this is actually, ironically, a demonstration of why it's there. Let's switch over to this one, because there's something wrong with that. I'm going to work it out here. So let's see the draft on this one. OK, so we're going to let's wait until we see it. None of this is rehearsed, by the way, so just so you know. All right, log in. It wants me to log in for my photos. It's worried about my privacy. Probably a good idea. All right, in I go. Let's move this guy back and go to the photo gallery here. OK, my name. OK. All right, we won't do that. We could have, let's try this guy. All right. I think I'm going to change to dev because this has got some issues. It's not even showing the code. Let's try that. OK. Looks like it sounds like a good thing that somebody created, but anyway, let's do this. Create a simple task manager app. It should be possible to define users. Each task has a title, a text and description, and some owners, users. All right, again, we'll look into this simple thing and see if we can get a better example of orthogonal persistence going. It's kind of funny, I've now probably jumped from the frying pan into the fire because previously I was using the thing that they're using at the hackathon, which seems to have some issues, and I've now jumped onto dev, which is like the live code version, but let's see what's going on with dev. All right, so again, let's turn this off here. Maybe that's the problem. Not to belabor the point, but again, you can see what's happening here. We just defined a user, ID, name, type, task, title, description, owners, and we've got users, which are a map from ID to user, tasks, which are a map from ID to task, and it's keeping track of next user ID and next task ID. But these are just variables, and these are actually the things that define persistence. So rather than running SQL against a database or something like that, you can see these functions are just directly accessing the data itself because it's just code, right? The data's in the code. So we're saying, let ID equals next user ID, let user equal user, ID equals ID, name equals name, users, map put users, ID user. It's just code. It's just logical abstractions. There's nothing, there's no examples whatsoever of data in there. OK, so let's see what's going on now. Actually creating quite a complex beast here. I said simple for speed, but all right, reviewing front-end code. So I don't know if you noticed, but the front-end code is actually React. And it's going to be interesting to see in the age of self-writing how long we go before there are specialized new front ends. Generating the back-end code was extremely quick. The time is being chewed up creating the front-end code. It's like Node and React and all the usual stuff. And now it's checking the front-end code, reviewing it for errors. And let's see. Ooh. It's actually done it, but we've definitely got some interesting issues that have just crept in. But anyway. OK, building the code, deploying it to the network. Come on. OK, thanks. All right, let's just do this quickly. So we've got hopefully some kind of task manager here, and we're going to add a feature, add a task, and add a feature. Well, not quite. Task. Yeah. Look into some strange behavior. Blah, blah, blah. Add task. OK, users. Dom. Oops. All right, I'm going to be off stage. We got delayed by some unexpected stuff. Yeah. Sam. All right. Add this task here. Owners. Yes. We can look into this. OK. So there we have this. We haven't, of course, added authentication to this yet, so somebody's also joining from home. Hi, thank you. And now what we're going to do is make a change that's going to modify this code. So let's just do a likes button. Add, make it possible to like a task. I'm not sure exactly why somebody would want to like a task, but it's going to help illustrate exactly what we're doing here. Yeah, there you go. All right, so, OK. I will get to demonstrate enhanced orthogonal persistence. It's the last thing I do. All right. Oops, let's scroll that back up a bit here. Oops, go back over here. Yes, OK. So this is where we want it to be. You can see the definition of task. It has an ID, it has a title, it has a description, it has a list of owners, which we've just tested out. And it also now has a field likes. All right? So next. We want to see it write a file called migrations.mo. There you go, it's added it. And it's writing it. So migration.mo is going to define how the old logic is transformed into the new logic because the data lives in the logic. So if we scroll down, you can see pretty much the whole thing. I mean, in this case, it's extremely simple, right? All it's doing is it's getting the old task and turning it into the new task by assigning the likes field to 0, because likes is new, so there's no data to carry across. All right, let's just go back to the chat. How's it going? It's updating it. And in a few seconds, I shall be able to show you how the existing data exists, or the old data still exists, but we've now got this new likes functionality. And it's funny when you look at this, but it's difficult to explain what a big step forward this is within the field of software. For how many years? I mean, I started off writing code to keep data in databases 35 years ago. And now, for the first time, it's possible to persist data without actually having to do anything special. You just write your abstractions. OK. Here we go. Where's my task? Someone's bloody hell. Is waiting. This is insane. Anyway, there's other people liking tasks, which is great to see. Let's see, I can like a task here. Gosh, whatever's going on. There you go, one like. I'm done. We've migrated the data without even trying, and we've done it in a way that guarantees data cannot be lost. So in the new paradigm, the new self-writing apps paradigm, the entire app lifecycle is a conversation. You talk to evolve your app, and as you talk, the code is written, and the app is actually upgraded. So in the pipeline, you've probably heard about inference ASICs. So the inference that the ensemble of AIs inside Caffeine is doing will in the future be accelerated by 10x plus. So the time that we're experiencing here between updates will be shrunk to a tiny fraction of what it is now. So in the future, development will happen at chat speed. You'll be talking, it'll upgrade the app, and when it upgrades the app, it's got to migrate the data. And it's got to do it safely, because these upgrades are happening all the time, and the user's not going to see if data's being lost. And this, I hope I've managed to convey some of the workings of orthogonal persistence, but this is how it's done. Collapsing the difference between logic and data, letting the data live inside the logic, and then being able to validate the transitions between these different states of logic in the different versions. And that is fundamental to how self-writing works. Thanks, everyone.
All right. I hope you've enjoyed your masterclass in orthogonal persistence. We're heading into our next fireside chat, where we're going on a bit of a journey. So obviously, one of the key premises of the self-writing internet is that it's sort of a natural evolution of the internet itself. This is where we've been hoping to head over the past couple of years. So we're going to retrace some of those steps over the next couple of minutes as we take a look at, from protocols to possibilities, the internet yesterday, today, and tomorrow. Feels like a very apt title for such a chat. Joining us on stage are two gentlemen, the first being Michael Casey, chairman of the Advanced AI Society, a familiar face to some of you who are keeping track of books that have recently been published in and around the topic of AI, data sovereignty, etc. So he's the perfect person to lead this chat. And of course, joining him on stage once again is Dominic Williams himself. Let's give them a warm welcome to the stage.
Right. Hey. I got a cheer as well. I feel very honored. Thanks for having me, folks. Flying visit was to MIT yesterday, where the Advanced AI Society, my new organization, is sort of dealing with revolutions in the area of AI agents talking to each other, not being aware that there's another revolution happening over here in this sort of developer to internet efficiency gains you guys are going for. So I watched the demo from June, when was it? July 3rd? When was it?
June 3rd.
June 3rd,
yeah,
right?
Sorry.
And I was kind of wanting something to go wrong at that point, right? I think it's actually quite constructive that you had errors here, right? Because in some respects I was thinking about a phrase where I was thinking, okay, the bug is the feature, in a way, right? Or the fixing of the bug. The bug is the feature because you're the fixing of the bug, right? Because it's actually that solving of that problem that is the efficiency gain here, right?
Yeah, so I don't know what happened. Well, I do know what happened there. I don't know what the bug was, but to put this in context, I mean, we've sort of moved forward this date by a month. So we've been incredibly aggressive. I was actually fiddling with code myself until yesterday, and there's teams of people working around the clock to make it happen. And some of the things I'll show you guys later, which weren't in the June the 3rd demo, enable this to be used in production. So you're working on a draft version of the app, and you can push the drafts you like live and so on. But yeah, you're right. Ironically, the bugs that happen also reflect the feature. So AI will always make mistakes and hallucinate, at least in its current incarnation. And it will improve all the time and make less mistakes. But as it improves, we're just going to push it harder. So it'll continue to make mistakes. Every time it improves, we're just going to push it into solving more complicated problems. And in addition to that, you could even have bugs in something like Caffeine, as we've just seen. Hardly surprising, given the pace at which it's been developed for this event. But nonetheless, the point is, you can't have this kind of paradigm unless you have firm guardrails that guarantee things can't go wrong. And that, of course, actually is one of the specialities of kind of Web3 and crypto. This kind of, you aim for kind of mathematical certainty in things and the provision of guarantees. So no matter how haywire the system goes, and no matter how haywire the AI goes, although what we saw here wasn't the AI, it was something else and got into the client, but no matter how haywire that goes, what's essential is that when you upgrade your app, and here we are just upgrading the draft app, but you can push that live and upgrade that too, of course. What's essential is that under no circumstances does any data get lost. Yeah. And the purpose of that is to enable us to move from kind of one-shot app creation, and we've all seen the demos where you can use AI to create like an impressive front-end game that just runs in the browser, for example. But real systems involve back-end data, and that data can be very important. I mean, even if the importance of data is very obvious in the context of enterprise computing, but it's also actually very important in the context of consumer computing. I mean, if you've got a photo gallery, and then you upgrade your photo gallery with the ability to store metadata that you specifically are interested in, like the locations of family gatherings, special dates, notes, or whatever it is you want from your photo gallery. This data matters to you. It really matters to you. And you'd be devastated if one time you log back onto your application or after an upgrade, you suddenly realize that some of the data had been lost. Even if you wanted something like a birthday planner or a wedding planner, it could be really bad if an RSV got lost, for example. So if we want to have self-writing, and I think it's the end, certainly one of the end games here is absolutely required, and we want to enable 5 billion smartphone owners to create and manage apps just by talking, then we have to make sure that even if there's a bug, even if the AI hallucinates, under no circumstances can the data be lost in this process of continual upgrades. And bearing in mind that as inference speeds up and we get a 10x speed up with ASICs, the cycle is going to be real quick. It's going to be talk.
Right. And you can imagine taking that lost data and then iterating on it and just getting worse and worse because of the speed.
Yeah,
right?
And the trouble with lost data is you may not realize you've lost it.
Right.
That's actually,
especially if it's going at ASIC speed, right?
Totally. You're probably working on a draft and you go, I like this draft, push it live, but there's no reason why you push a draft live and do a few more revisions, and 50 seconds later, you're not pushing another one live. And in fact, you may not even be checking your live app. You may just be working in the draft, and whenever you get to a version you like, pushing it live. So you may not even want to check in practice, or a consumer might not check.
I want to get to the speed part of it, because you just said something on stage a moment ago about updates will happen at chat at chat speed, which I was starting to think like almost eventually it's idea and write,
Yeah.
right? And so that there is a phenomenal breakdown of time, and this is, I think, this capacity to move everything faster. But just to bring it back to the relevance of the perpetual data issue here, I think you and I have been in this space, in the blockchain space, for quite some time, and there's been this sort of like, okay, what is the use case for the provenance, right? The idea that you've got the persistence as a concept has been there in blockchain for a while, but if that persistence or that consistent sort of like broad-based compute problem is an expensive, inefficient exercise, and it really doesn't make it easier at the UI side of it, or in this case, the developer end, then you're never making it valuable. But what's interesting here is that precisely because of the necessity of resolving this bug problem and the continuation of the updates, you've suddenly transformed the value of persistence across a blockchain structure into the use case. And so now, and I was thinking, I was going down the vibe coding rabbit hole a little bit before I got here. It's like, okay, how are you different from the current vibe coding on the LLMs? And a number of these kind of like, demonstrations out there about people like, oh, if you've made a mistake, you have to start all over again and sort of re-prompt everything to get back to where it was. And the assumption is, look, because there's always going to be mistakes. And so now all of a sudden, because there's always going to be mistakes, you've suddenly got an efficiency gain at the front end by virtue of like resolving those problems. So on the basis of that, what is your message to the vibe coding community about how this is different from vibe coding? Because it can still feel like that's all you're doing, right?
So, as I said this morning, these different paradigms are going to coexist. So there's going to be craft coding, there's going to be vibe coding, there's going to be self-writing, and there's going to be the fluid web. And in the fluid web, there isn't even a pre-built UX. Like the AI is creating the user experience on the fly and combining functionality from different apps into one experience for you. And when paradigms change, you always find that new tech stacks emerge because they're more suited to addressing the specific problem domain. And we saw that, of course, with mobile. Microsoft tried to sort of port Windows onto mobile, and people preferred iOS and Android because they were built specifically for that problem domain. And today, about 50% of the code in the world is being written by AI already. And I describe myself as a vibe coder now. I tend to use the command line tools and constantly switch between different models and so on. But you can palpably feel these models getting more powerful. Mm-hmm. And I think there's a domain in which, experienced software engineers are going to continue to magnify their productivity using AI. And there's also a domain in which people are going to just, a bit like go with the vibe fully, if you like, just want to have the AI build everything for them. Interestingly, with the demo, I don't know what's happened. We got a few bugs in at the last minute. But what I've noticed with Caffeine is, even though the code is there, I very rarely find myself looking at the code and wishing I could change it. And actually, of course, you can tell Caffeine, if you're an engineer, you can say, hey, modify this code at line such and such, in file such and such. You can kind of vibe code it if you want. But such is the convenience of just being able to talk. Even as an experienced engineer, you tend just to go with the conversation. And it's a different paradigm. I think there's horses for courses. I think all of these things are going to coexist. We're going to see craft. I think there's going to be less and less craft coding in truth, because
isn't it also, there's this distinction between programming and coding people talk about, right? The programmer has got this sort of bigger vision about what has to be built and the functionality of it, the experience and everything else. The code is literally that writing piece. And it's a little similar to the world that I'm in as a journalist, right? Like, the editing job
Yeah.
is this functional thing, but the ideas, the creative thing, hopefully that persists, right? Is that where this is all going? Because this is a big picture title, right? We're going from internet yesterday, today, and tomorrow, protocols to possibilities. Like, give me that vision here about what is how does this play into this future of where creativity and programming and everything else goes, right? And also the sort of potential democratization of it all.
Totally. Look, I think very quickly we're going to find that only a small minority of engineers, developers, whatever you want to call us, can actually write code. Most developers will just be using natural language.
Right.
And I think in the long run, creating apps and services will become almost as normal as performing an internet search. So it'll become very normal for someone to decide they need some specific functionality. It might even be just transiently. It might be a throwaway app that they just need for one thing, and just to open their phone and talk to a self-writing platform and create what they want. I also think that as this technology advances, and I mentioned, it's palpable the speed at which AI is advancing, and as frameworks that enable AI to go further within a safe, with guardrails that provide safety advance, it's going to be possible to create more and more sophisticated services just by talking. And I think, in the next 10 years, we're going to see self-writing kind of take over the enterprise space, because the speed and efficiency gains are just incredible. I mean, we're talking oftentimes less than 1% of the cost, less than 1% of the time to market. Yeah. And what's magical is when you build this using decentralized networking technology, you also get other things too. So these apps that are deployed to the internet computer are tamper-proof. So they don't need protection by traditional cybersecurity. They're protected by the mathematics of the underlying network protocol that creates this specialized cloud environment. And that means they run safely without firewalls and without anti-malware and things like that. They're also incredibly resilient. People often call this property being unstoppable within the fault bounds of the network. And they're also sovereign. So people own the code. They've created it by talking. They wrote the code by talking. They own the code. They own their own data. And they're not beholden to any specific platform provider. So there's nobody who can sort of switch you off. And if you're a corporation and you're not building maybe on a public network, you're using the same technology, like in the form of Utopia, say, your application is running in a specialized cloud designed to support these apps created by AI that's actually replicated across all the main, if you want, cloud providers. And if you decide one cloud provider is too expensive, you can literally just switch it off in real time, just flick a switch, and everything will continue running without a hiccup. And it'll still be secure, it'll still be resilient, and then you can maybe decide you want to do some stuff on-prem, and you've got some hardware and a data center, and that's okay. You control it.
What's needed from an adoption perspective for this? I mean, obviously, you're going to be out there promoting the value of all of that, and that's a very appealing paradigm that you can think of as an enterprise. Great, I can be very flexible around this and not worry about what's going to happen to all of my code. But we currently have security specs and all these sort of requirements placed on there, and then basically there are audits done of the quality of the provider and so forth. And we've seen for quite some time a resistance amongst mainstream enterprises to embrace things like decentralized storage and decentralized compute because they can't trust it, right? How do you get them across to say, no, you can trust this, and what's the demonstration effect of showing that this mathematical proof is in fact enough that you can just let the thing go in that regard?
Well, I think there are multiple parts to that, to the answer. I mean, number one, I think the Web3 industry's reputation is a bit tarnished, and probably rightfully so. It started off really with a bunch of pioneers who are obsessed with the technology and what was possible, and the things that could be done by using math to build platforms. And at some point, the industry kind of realized that nobody can directly experience these platforms. And so you can have a token in these platforms, and you can just attach a story to the token, and the token's the product. And then began the descent to the bottom. So that's definitely a challenge with respect to Web3. Another part is...
This is a very different experience. This is literally just coming up and showing...
Yeah. So I think what's very important with this is now people can, for themselves, experience what a decentralized network is. This is something that enables them to create things of value, things we haven't got to yet with Caffeine, and things like the App Store. Gives people a way of becoming industrious. They can get to market faster, they can reduce costs, they can create crazy things like hyperlocal social networks for their extended family. This is palpable utility and value, and it's got nothing to do with a token. So I think that's a big one. People can experience it. With respect to the enterprise, though, that's a slightly different question. I think many enterprises and governments will not wish to immediately build on a public network. Right. So in the case of the internet computer, the people running these special node machines, it runs on special hardware, and there are independent node providers who run this hardware, and those node providers are identified. Right. So it's a little bit different to your traditional kind of blockchain-y kind of thing where everyone's anonymous, and anyway...
as an enterprise, you can choose to have these identified...
So these people have put their names out there, and they're legally liable if they do anything and so on. So it's not quite the same as building on a blockchain. Anyway, of course, traditional blockchains, you can't really create anything on them. They're just tokens and a bit of financial logic. But I still think, even despite that, a lot of enterprises will prefer to create their own networks. And when they see that, in fact, it's just a sophisticated network layer that they're running over the top, if they wish, of traditional cloud providers, that just gives them way more security, way more resilience, and this flexibility to create things by talking. I think that we've already been speaking to people in the space and enterprise.
But it might also be that,
really
in fact, the economic pressure of all of a sudden there's some kid just in his basement has suddenly spun up some major competitor to Salesforce because they could spin it up with just this quick, self-writing model. And it's like, okay, we didn't trust it, but we're just going to have to trust it because look what these kids are building, right?
I think that's going to happen at some point.
So, I mean, the economic incentive part of it could just drive you in that direction if it plays out.
So one of the other things we're going to hopefully show you guys later is this app store that's within Caffeine, and because the AI will refuse to build anything that's evil, albeit there are ways of tricking it, we can make it much more open than the Apple App Store. Of course, people will receive a much bigger share of the revenues generated. So you can publish your app for others to use for free, or you can publish it for $1 a go or $100 a go. It's up to you. And there's a different thing going on, though, because when you go to the App Store, you'll see a button that says clone. You don't see a button that says buy. You see a button that says clone. So even if there's a price, you can immediately clone it, and it'll be put into draft mode. It's only if you want to push it live that you pay. So you clone the app that someone might have spent thousands of hours developing, and now you can start modifying what you've cloned. And that's pretty cool. And obviously very different to the prevailing paradigms where you get an app and you take what's there. But in addition to that, you can customize, you'll be able to customize that app that you've cloned from the App Store. And it'll still be possible at some point to merge in subsequent updates and improvements to the original app. So these apps are kind of fluid in a way, which comes back, of course, to, brings us back to orthogonal persistence. So if you think about what makes, I think that this is the first self-writing platform. I don't think it's the last. I think a lot of people are going to want to build self-writing platforms, and they should. But what makes this particular self-writing platform great is three cool features. Number one, which come, of course, from, have their origins in crypto. Number one, when you deploy to the internet computer, or a private internet computer like Utopia if you're a corporation or government. Number one, when you deploy, your app is tamper-proof. That means it runs securely without the need of a firewall or anti-malware and intrusion detection and all that kind of stuff. And if you think about the problems you'd face if that wasn't the case, the benefits are obvious. Imagine that AI has a hallucination and it's managing all your security for you. And the next thing, your data is being exfiltrated, you're getting your system encrypted by ransomware or something like that. Number two, within the fault bounds of the network, obviously, your app is unstoppable. It's a blockchain term, which is another way of saying it's highly resilient, because probably you won't have so many replicas. It's actually, for cost reasons, it's actually unstoppable, but it's incredibly resilient. And again, AI makes mistakes. So imagine if AI was responsible for all of that. Well, it first of all greatly complicate the design of your app, and that's going to slow it down and make it harder to upgrade. And again, it might make a mistake and the thing would start working. But the third one, of course, is enhanced orthogonal persistence, which is the more subtle one. Not only making sure that, given the current powers of AI or the current powers of an ensemble of AIs that are building, they can push the sophistication of the apps built much further, 2 or 3 times further than you could do without this simplification and the collapsing the difference between logic and data. And crucially, that as you're mutating this app, and this is how I think, going back to your original question, how should vibe coders think about soft writing? My answer is that apps need to be more fluid. And instead of these long development cycles, we need to start thinking about upgrades happening at the speed of chat. And this is almost like anathema to traditional craft coders like me. In the past, you'd build a system, and if there was a lot of critical data in that system, an upgrade would be a big deal. There'd be migration scripts, and there'd be people on hand, backups, and people on hand.
Organizational structures built around the upgrade cycle. It's like an integral part of, Microsoft defines its life by those upgrades.
And a lot of people are involved. You bring the app down. It's offline oftentimes, or you do it in the middle of the night, but then you've got problems with time zones. You bring it down. There's a whole bunch of people on hand ready to roll back if there's a problem. But in the future, apps are going to be much more fluid. So I don't know if any of you guys have ever tested inference with ASIC acceleration. It's extraordinarily fast. So probably by the end of this year, you're going to be seeing this sort of speeded up by several times. Wow. And you're just going to be talking, mutating your app. It's going to be seamlessly upgraded. And so you see it's a much more fluid process.
The innovation and development cycle is, for the broader economy in this sort of environment, is just going to be accelerated rapidly.
Totally.
So I just want to shift gears a little bit, because as I said earlier on, I came from an event in MIT where we're, the exercise that people were looking at there was trying to figure out what kind of a protocol structure can we create for communication, for coordination, for payments, and all these sorts of things that would allow these independent autonomous AI agents to work with each other, right? And when I think about that, I think about some of these ideas that people have been putting out there about this sort of post-web thesis, right? That in fact, we're going to quickly move into a world and when this human interface, the web, the things that we're used to reading, the apps, all those things which are all designed for humans are going to become redundant because the actors on that internet are actually going to be these agents, right? What you've described for us, what you're showing these demos, is the AI-based development of what are essentially human interfacing webs, right? Where, all of those ideas. Is that a dependency there, or does this same structure lead to a world in which you've got really AI performant, whether they're called apps or whatever these things are that would actually be operating with each other, or is the post-web thesis actually also wrong?
No, I think it's correct. Well, look, the first thing is, post-web is right and wrong at the same time. So the web is already being superseded. When you search on Google, because of the competition, they're forced to create, use AI to create information summaries. It's a big problem for Google, actually, because their whole business model is based around getting you to click on lots of different links. And now, ventures like Perplexity, forcing them.
Yeah. In the media world, like all of that traffic that was dependent on it, all these newsrooms are just going to dry up because they just don't get the traffic.
Well, and that's a problem too, because then there won't be any information created for AI to summarize. So there's a lot of disruption coming to the web. So that's the piece that's completely correct. I do think at the same time that these things will coexist. I think so there are these four main paradigms for creating functionality on the internet. Craft coding, which was, I actually did a bit of that before the web was around, back in very early 90s. Then you've got vibe coding, where you're kind of writing code and also getting AI to write some code for you. Then you've got self-writing, where it's, the whole app lifecycle is just a conversation. But then there's another one that's coming, which is the fluid web. And to get a sort of idea what the fluid web what it might be is, look at what Perplexity is currently doing for data. You give it a prompt, which is a bit like a search, and it draws in information from lots of different sources and assembles it into something akin to a dashboard or one new piece of content. And the fluid web, that I suppose is an example of the fluid web, but the fluid web will go further and combine functionality. So it would be possible to create a layer over the existing web which transformed every existing website into a kind of microservice. And then, in the same way that Perplexity combines information from different sources to create your kind of unified information resource, it would be possible to combine the functionality of these different microservices.
As a user, I'm not going into the web, I'm going into my interface. But underneath that, web is still being used as a mechanism.
Well, and the functionality, the data and the functionality is coming from the web, but you are now interacting with a user experience that is generated on the fly. Probably you've assigned a style to it. You never go to the websites anymore.
Right.
Nonetheless, that will coexist. There are some cases where if you've got an app that you want to use yourself, then why wouldn't you design it exactly as you want? Maybe you don't want the generated interface. But you probably hear me talking about fluidity a lot. And on the back end, of course, things like orthogonal persistence and the way that backends are being built by Caffeine is very fluid friendly. It's designed for this. So I think one of the things we'd love to see, and when we have, get a bit further with Caffeine, is a world where you've got these self-defining. This is actually what happens already with Caffeine. That the back end has a definition and it has an API, and people create maybe just the back end and not a front end. And you see how long it takes for the AI to code the React front end, albeit that'll come down by an order of magnitude. Yeah. So you can imagine people never develop a front end. In fact, what they do is they just define what their app should do in terms of functionality. Sure. The back end is created. The back end has got some, will serve some kind of description of its functionality, the API, if you like, the public API. And you could have people all over the world, or inside a corporation, for example, just creating these little units of functionality, bearing in mind that with orthogonal persistence, the code and data are kind of one.
Yep.
And they can be mutated and so on and so forth. And then a sort of fluid interface, a fluid user experience would be created by AI on the fly that combines the functionality produced by, if you want to call them microservices or apps or whatever they are. And then eventually I think that might be where the web goes, with the exception of a few specialized applications where for whatever reason it makes sense to invest a lot of effort into the user experience. But I think for a lot of applications, user experience is an afterthought. It's just purely there to enable people to access it, and therefore a lot of time, huge productivity gains will be achieved just by simply defining the back-end logic and allowing the front end to be dynamically created. And because it's dynamically created, it can arbitrarily combine any of these different web functionalities.
It's like a very different user experience in the future of what that's.
It's the kind of thing you see on sci-fi.
So yes.
Yeah.
So we're out of time, but I just want to throw one last thing at you, and it's more just to step back, look at this from the perspective of DFINITY itself, right? how important is caffeine? Like, it feels like you were a big thing, you know, I think 4 or 5 years ago when I was in this space, drifted out of the public eye a bit. Is caffeine, what is this? This is your 2.0, this is your
It isn't,
renaissance. How are you thinking of this in terms of what this means for the future of DFINITY and ICP? And you've got to be quick as well.
Yeah, well, absolutely, it's crucial for the future of ICP. I mean, I've already talked about Internet Computer 2.0 and its self-writing. I believe that in a matter of years, most people will think about tech stacks as being self-writing platforms.
Right.
And there's just a massive market for this. And for the Internet Computer, it not only helps realize a lot of the sort of deep computer science work that we've done, things like orthogonal persistence and developing new languages and creating a network that can scale and so on. But it's also important for its ecosystem. So it's crucial to everything we do, like it's front and center going forwards. Self-writing internet is probably the #1 objective of the Internet Computer project. Yeah.
All right, on that note, we'll call it quits, but thank you very much, Dominic, for
Thanks,
for
Michael.
this.
Hey, man.
All right, as I'm sure you've guessed correctly, I now once again have the pleasure of dismissing you for a round of refreshments, networking, and of course, caffeine experience pod testing in the back.